Hi everyone, I hope you are okay. Now, in this lesson, we will learn working with normal distribution and using a linear combination of random variable. Now, we can start. If a continuous random variable x has a normal distribution, then multiply x plus b, where a and b are constants, also has a normal distribution. As you remember, when we work on the normal distribution, we had made something. One of these we use z values. For example, x x value in the normal distribution means the first value is nu or expectation, and the second value is variance or sigma square. Then we had converted to z value, and z in the normal distribution the expected value is 0, and the variance value is 1 in the z values, because we had used to z table. When if we want to convert to z, or convert to z, we had used to z equals to x minus nu or expectation over standard deviation or sigma. If we rearrange this equation, means x equals to nu plus z multiply standard deviation. And as you remember, nu and standard deviation are constants. So this is a linear combination of a random variable, and both z and x follow a normal distribution. So we can use normal distribution when we come across to normal distribution or linear combination. Okay, now we have some example about linear combination and normal distribution. The masses in kilograms of small bags of rice and large bags of rice are denoted by x and y. In the sentences, I knew the small bags called x and large bags called y, respectively, where x the normal distribution expectation is 2.1 and variance is 0.2 square. And for the y, in the normal distribution, expectation is 6.6 and the variance is 0.4 square. Okay, find the probability that mass of randomly chosen large bag is greater than 3 times the mass of randomly chosen small bag. It's a keyword, 3 times. 3 times means 3 multiply small bag, 3 multiply x. As you remember, in the last lesson, we had learned variance x plus x of variance value in equal 2x of variance value, 2x of variance value. So when they say to us 3 times mass, it means 3 multiply x. Okay, now we want to find the probability of large bag greater than 3 times, large bag is greater than 3 times small bag. So y greater than 3 times small bag, and it means if I carry out 3 times x, the other side of inequal sign, so it becomes y minus 3x greater than 0. And in the first step, I want to add a name this process. For example, this is w y minus 3x, and I want to find expectation. So the expected value is w. The second step, I want to find a variance of w. Okay, w is y minus 3x, 3x, and the variance of y minus 3x. The y minus 3x x's expectation is the expectation of y minus 3 multiply the expected value of x. But in the finding variance, a bit difference. As you remember, this process equals to the variance of y plus negative 3 square multiply the variance of x. Okay, it means the expected value y is 6.6 minus 3 times 2.1, it means 0.3. And the other value, it's called variance. The variance of y 0.4 square, it means 0.16 plus 9 multiply the variance of x 0.2 square, it means 0.04, and the variance is 0.52. So our new value variance is in the normal distribution. The expected value of y 0.3 and 0.52, because 0.3 means new and 0.52 means variance, and we want to find the probability of y minus 3x greater than 0. So it means the probability of w greater than 0. And we need to now we need to convert to z value, and so it means the probability of z greater than, you know, uh, w 0 minus nu 0.3 over standard deviation, or sigma. Sigma is the square root of variance. It means 0.52. And I want to look at the results shortly. So it means minus 0.416 minus 0. minus 0.416. Okay, now I want to draw the normal distribution graph, and I want to show you something. This is a normal graph, and the middle of the point 0, our value is minus 0.416 here, and we want to find this area. As you remember, this area is big area, so phi minus 0.416, the same phi 0.416. When we look at the z table, we can find this value, and this value is 0.661 to 3 significant figures. Okay, now in the other example, the lifetime in months of Conti batteries and Tift batteries have the independent distribution for Conti 21 and 1 to 1 square. For the Tift batteries in normal distribution, 7 and 2.3 square respectively. So in this in the firstly, for Conti batteries, the normal distribution 25 1 to 1 square, and Tift batteries in the normal distribution 7 to 2.3 square. What is the expected total lifetime and variance for randomly chosen Tift batteries? These sentences is very important, and we have a keyword for randomly. For randomly, not the same 4 times Tift battery. As you remember, in the before example, they said us 3 times small back, but now they say 4 randomly chosen Tift batteries, and it means not 4 multiply T. It means T plus T plus T plus T. Okay, because they set us 4 randomly chosen Tift batteries, not 4 times. Please notice that. And now we want to expect the expected value of T plus T plus T plus T plus T plus T, and the variance value of T plus T plus T plus T. And now it means 4 multiply the expected value of T, and it means the expected variance value of T plus the variance value of T plus the variance value of T plus the variance value of t, it means 4 times the variance value t. Because one more time, the variance value of the 4t, it means 4 square multiply for the variance value of t. So if I would to write this process, it becomes wrong. Okay, it would be wrong, and we want to these values, and expect the expected value for t 7. It means 4 times 7 and 28. 4 times variance, it means 2.3 square, 2.3 square. And I want to look at the result for short time, and 21.16, 21.16. Okay, now the other section, find the probability that the total life of 4 randomly chosen TIFF batteries is longer than 30 months. Okay, now we want to find the probability of 4 randomly chosen TIFF batteries greater longer than 30 months. I want to give a name these sentence, 40 W, for example. I want to find the probability of W greater than 40. It means this situation is I want to W expectation for W means in the normal distribution, expectation value is 28, variance is 21.16. Okay, and I want to this probability convert to Z, so it means the probability of 30 minus nu over standard deviation means the square root of 21.16. Okay, and now this is this situation, it means the probability of Z greater than 0.435, and I want to draw a normal graph, a symmetrical graph, and the middle of the point is 0 and 0.435 here, 0.435, and we want to find Z greater than 0.435. This area is small area, this area is small area, this area is a big area. When you look at the Z table and when you find the phi, 0.435, you find the big area value, but you want to find the small area. So for the small area, you should use or make 1 minus phi 0.435. Okay, And this process means 0.6682, 0.6682, 1 minus 0.6682, and it means 0.332, two significant, 3 significant. And the other section, what is the probability that the lifetime of randomly choosing Conti battery at least, please notice that it's a keyword, 4 times. So Conti battery is at least 4 times, chosen Conti battery is less at least 4 times that of a TIFT battery. So we want to find Conti battery at least 4 times that of TIFT battery. So it means Conti battery greater and equals than 4 times TIFT battery. We want to probability of C greater and equals than 40. If I carry out the other inequal sign, it becomes the probability of C minus 40 greater and equal than 0. And the first time we should find the expected value of C minus 40 and the variance value of C minus 40. It means the expected value of C minus 4 times the expected value T. It means the variance value of C minus, plus negative 4 square multiply the variance value of T. So it means, okay, now it means C, I want to look at, yeah, it is here. It means 25 minus 4 multiply 7, and it means 1 to 1.1 square plus 16 multiply 2.3 square. Okay. Now this result is negative 2, and the other variance value is 80. The variance value is 85.9. 85.9. Okay, and I want to give a name this process. So it would be W, and W means C minus 40, and we want to find the probability of W greater and equals than 0, and okay, and the W in the normal distribution means the expected value is negative 2, the variance value is 85.5, 85.9, and we convert to Z, so the probability of Z greater and equals than 0 minus nu negative 3 over the square root of 85.9. Okay, now this result is the probability of Z greater and accused than 0.324. And if you draw the normal distribution graph, zero is here, and 0.324 here. You want to find greater than 0.324, but this is a small area. And if you look at the Z table, you see the big area value. So if you want to find the small area, you should 1 minus phi 0.324, and 1 minus phi 0.324 0.6270, and it means 0.373. Okay. Now in the other example, a melamine worktop is made by joining sheets of melamine and chipboard. Melamine and chipboard. The distribution of thickness of the chipboard C in millimeter is C means in the normal distribution 37 and 0.3 square, and the melamine the distribution of the thickness of the melamine melamine is the normal distribution 0.01 square. This is the distribution of chipboard in the melamine. This is the distribution of melamine. And find the assuming the distribution are independent, find the mean and variance of the thickness of worktop if the melamine sheet is added to just the top surface of the chipboard. Only top surface of the chipboard. So we should find only top surface of the chipboard means only chipboard plus melamine. So we should find variance of chipboard plus melamine, because we will made for only top surface of the chipboard. So one time we should use 1 times melamine, and this is the expectation, the expected value C plus the expected value M. This is the variance value C plus the variance value M, and it means the expected value of C 37. The expected value is of melamine is 1. It means 38. For the variance and the variance value of C is 0.09, and the variance value of M 0.0001, and it means 0.0901. This is a variance value for only top surface chipboard. Okay. Now the other one, both the top and bottom surface of the chipboard. So top and bottom, for the top and bottom, they said us assuming the distribution are independent, not two times, and discretely both and bottom. So we should find the normal for the normal distribution chipboard for the bottom melamine plus for the top melamine, not two times, because for the variance would be different. So we should find the expected value of C plus M artı M plus M, the variance value C plus M plus M, and it means the expected value C plus 2 times the expected value M, the variance value C plus 2 times the variance value of M. It means 37 plus 2 multiply 1, it means 39, and it means 0.09 plus 2 times 0.0001, and it means 0.0902. Okay, now in this lesson is finished. So the other for the other lesson we will go on where we stay. As now, have a good lesson, have a good day.